Hello all, welcome to Module 2, Deep Learning. So in the previous video, we saw and we understood and studied the basic definitions of deep learning. So giving a small recap of the previous video, deep learning is a subfield of artificial intelligence and machine learning that uses algorithms inspired by structure and function of brain's human network. Let's delve into the second module of deep learning. So what are layers? As we know, this is called as an artificial neural network, which mimics a biological human neural network. So this artificial neural network consists of neurons. These are the neurons, circular structure called as neurons, organized into layers. So here we have the primary input layer and this is the output layer, the predictions. And whereas this hidden layers consist of neurons which makes the learning happen. Another detailed explanation of artificial neural networks is as below. Artificial neural networks are comprised of large number of simple elements called neurons, each of which makes simple decisions. Together, the neurons can provide accurate answers to some of the complex problems such as natural language processing, computer vision, and artificial intelligence. A deep neural network consists of multiple hidden layers. Commonly, deep neural network consists between 2 to 8 additional layers of neuron. When we have additional layers of neuron, the outcome is very obvious. It has a better learning. The complex learning context uses deep neural networks. Now, it's time to understand the actual working mechanism of a deep neural network and a neuron. A neuron, also called as a perceptron, is a mathematical function which takes one or more inputs. Inputs are x1, x2, x3 and multiplied by a factor called as weights and passed on to an activation function added with the bias. So in the subsequent slides, you will understand what is weight, what's an activation function, and why we need a bias. So the input are x1, x2, x3 to the neuron, and the output is A, the result of the activation function Z. Now let's calculate or let's devise the equation. The Z neuron is equals to x1 w1, input x1 multiplied by the weight w1, input x2 multiplied by the weight w2, input x3 multiplied by the weight w3 plus bias, and this Z is being applied to the activation function A. Let's understand certain basic concepts. Mathematical function. Since this word comes across this deep learning module at many places, let's have a refreshing thought on this. I'm sure that the people who may know about functions very well or who are good in mathematics may not need this, but still refreshing this basic concept is a good thought. What is a mathematical function? It's like a machine that has an input and an output, and the output is related to somehow to the input, so that's called function. So you have this mathematics, you have this table number 2. So the input is 0 multiplied by 2 is 0. Here you have an input, a data set of inputs and output. This input is related to this output in some way. It's a multiplied value of 2. Hence this becomes a function. A function is represented as f of x. Here this is called as a function name, obviously f, and this is the input, and there is some relativity between the input and the output, and the output is related in this way, the squared value of the input x. So f of 1 is equals to x square is nothing but 1, f of 2 becomes 4, f of 3 becomes 9, and so on. Another important and interesting part is the activation function. In an artificial neural network, an activation function, this is a neuron, an activation function maps the node's input to the output, and the direction or the redirection of the input to the output depends upon which activation function you use. There are multiple activation functions like sigmoid, tanh, ReLU, leaky ReLU, and many others. So the selection of the activation function depends upon the complexity and the objective of the network. So activation functions determine the output of a deep learning model, its accuracy, and also the computational efficiency of a training model, which can make or break a large-scale neural network. So coming back to the previous slides, we have multiple neurons. So this multiple neuron receives an input and produces an output. The activation function determines which neuron has to be fired or not fired. When I say fired, it means that producing the output to the next neuron. So the activation functions determines which neurons in this layer needs to be fired or not fired to produce an output, and that sequence of firing depends upon the prediction or the complexity of the problem this particular network is handling. So the function is attached to each neuron in the network and determines whether it should be activated or not based on the neuron's input, and depends upon the model's prediction. An additional aspect of activation function is that they must be computationally efficient, because they are calculated across thousands or even millions of neurons for each data sample, meaning each and every deep neural network has millions of neurons, and each and every neuron is responsible for the prediction on which that particular network is actually working for. So this activation function works as the actual firing element. This determines whether this being fired or not fired. So when they mean computationally efficient, it means that this function has to be efficient to take the right decision, because the right decision this activation function takes will determine the output. Presenting you a deeper role of activation function in a neural network. In a neural network, the numeric data points called inputs are fed to the neurons in the input layer, as we know. Each neuron has a weight, and multiplying that input number with the weight gives the output of the neuron, which is transferred to the next layer. Getting back. So here we have the inputs, weights multiplied with a bias, inputs multiplied by its weights and added to the bias gives a output Z, but it's only a transitional output. This transitional output is fed to the activation function. So let's summarize what we studied today. We have an input, and input has been multiplied by neuron's weight added with a bias. A detailed video about the bias and the activation function will be our next. So this input added, multiplied by the weight added with the bias, will be fed to the activation function, and this activation function determines the clear output, what is supposed to be fed to the next neuron. Thanks for your patience, your watching time, and your encouragement.